All right. So, coming from the Netherlands, he's a staff engineer at WeTransfer, known for his focus on code architecture and team processes. As a key contributor to the iOS community, he shared his expertise through his blog, Swiftly. We are so glad to have you today. Let's give a big shout out to Antoine van der Lee.
Muchas gracias. All right. Thanks a lot. Muchas gracias. It's funny. I had a conversation with Facundo beforehand, and he was asking, like, do you want to be the first speaker on the second day? So I looked up, when is the after party? And I was like, okay, it's not on the first day, so I'm safe. But it's ironic that the classical Dutch rainy weather makes it that we had to start a little later, isn't it? But it makes me feel at home. So first of all, I'm super happy to be here. It's pretty far. We started actually quite a while ago. This is a conversation in 2019 I had with Facundo, and yeah, we were planning on 2020, and I would go to Argentina, and I was excited. And then something called COVID came around, which was super sad. But I'm so thankful and happy that we could still make it happen and that I'm here today. But I'm not here to talk about Twitter threads. Does anyone recognize this bird? You must know it, right? It's the Swift bird, and I tried hard to find one that actually kind of fits the logo that we all love. And I'm here not to talk about macros of the Swift bird. It's the first dad joke today. I won't make too much. But I'm here to talk about Swift macros. And when I was at WWDC, I always looked like, what is the next talk I want to do? And Swift macros was clearly one that I wanted to dive deeper into. And I'm not sure if you're aware, but the Swift team has proposals. I think you know those. They have a roadmap, but they also have vision documents. And this is the vision for macros that existed before macros even got released at WWDC. And it's like the story behind why the Swift team thinks they need macros. So I want to zoom in on a part, and there's a few things I want to highlight in this paragraph. Because the key is, with macros, you might think we all need to write macros now today, but my message today will be to you that I don't necessarily think that is true. The core team wants to create more focus, keep the core language smaller, and they want to create more time, right? If the core team can focus on more fundamental stuff, and we as contributors can potentially, reduce the desire of synthetic sugar by creating macros that solve that, the Swift core team can eventually use that as input to later potentially bring that back into the language with improved performance. They can do much better things than we can do with macros, even though they are pretty advanced. But yeah, if you're really into macros, make sure to read this document so you get a bit of the background story. And I'll share more about this later in my talk. But yeah, you can say that macros will help the language grow. So anything we build with macros can be inspiring. And there are actually a few things that macros could have been, a few years back. But first, a new macro released during WWDC. So this is actually a macro that you could have been used already. It's great for performance in Swift UI. It allows you to step away from the published property wrapper. Highly recommend you to check it out. Swift data contains a lot of macros. And I actually think that Swift data wouldn't be here today if macros weren't here. So maybe they knew beforehand that macros were coming, awaiting that, because it would make their lives much easier to implement Swift data. This is a so-called attached macro, and this one as well, and it even shows you that you can put in parameters, if you will, to highlight, in this case, that the name is a unique parameter. Now, this is probably the one that we all have used the most. If you now create a new Swift UI view in Xcode 15, you might see that this is going to be used instead of the preview provider protocol. It also works with UIKit views, which is pretty awesome. It's also my first time that I got Sherlocked, one of my open source projects, so I'm glad it wasn't one of my other things. But yeah, the preview macro is a great example. And what you can do in Xcode, you can right-click that macro, and it will show you the code behind that macro. And that is pretty interesting. So this tells you actually that a macro is nothing more than just generating code. And I want to highlight here that the name of the struct is pretty, like random. But it's on purpose, because the macro generates code, which is being compiled in your whole project. So if that name would be a duplicate, it would be a compile error. So the macro system actually helps you to create those generic kind of names, or like random names, to prevent those issues. The magic is that there is not much magic, actually. A macro only has access to the file it's been defined in. That makes it restrictive, but it also allows you to not do things you shouldn't do. It generates code. It's basically removing boilerplate code. So things that you do repetitive will be replaced by the macro, and that could be a really great way to reduce the boilerplate code in your project. Since it generates code, you can put breakpoints in there. You expand the macro, put a breakpoint, and it will just work as regular code that you have. It's also testable, both on implementation side, as well as on the macro logic, right? So if you write a custom macro yourself, you can write test, if you will. And this is a nice way to think about it, if you ask me, because it simplifies things. But I also want to highlight here that if you think macros are too complex for you, write the code just in place. Don't use macros. Keep it simple and stupid for yourself. This is really an advanced feature that we're covering today. I'm still excited, but yeah, just so you're aware. And I said it briefly before, and I took this from the vision document, actually. These are features that could have been developed by a macro if we had macros back in the days. And Codable was, for me, a pretty big feature. Swift 4.1, I think. Can you imagine that we could have built that with macros, and the Swift core team could work on build performance back then already? And result builders are even more complex, so that really shows the power of macros. So this is how we know Codable today. But if you had a macro, it would basically look like this. And if you then expand that macro, like we did before with the preview provider, it will basically look like this. This is being done already now with the Codable protocol. Behind the scenes, you don't have to define the coding keys. You can do that if you want to override it. Same with the initializer or the other method. And this is a typical macro with multiple rows, which I'll explain later. So why should you write macros, or why not? I have a few examples of benefits that I think empowers macros and that make it really cool feature. Here we have an enumeration, and you might think it's a bad example because you can use the equatable protocol, but it is a great example to explain this concept of boilerplate code that you want to replace. We have two properties, the isDog and an isCat, and mostly because the associated parameter, the curious, it might be a little more difficult, you think, to use the equatable protocol. And in the bottom, you can see that you can use the isCat or isDog right away. We can replace this by a case detection macro, and the macro will really shine if you have another enumeration where you want to use this. In this case, the environment enumeration, you don't have to write all those properties again yourself. You can just add that macro and access that property right away to potentially check that you're running on production and you don't want to show that debug menu. Always be aware. Compile time safety. This I think I like the most. You can actually interact with the compiler. The macro is basically just a compiler plugin. So you have like a context. You can communicate with a compiler and tell him like, hey, the code I'm evaluating here is wrong, so you should now throw an error. And comparing to this URL, I mean, I bet we've all written this before. Let's just use an exclamation mark. This might actually be your only exception in your code base where you can still use an exclamation mark, but you're still feeling bad because SwiftLint is mad at you. You don't want to do this. And on top of that, you are not sure that this code will work actually, and you will only find out at runtime. So much better would be to have a macro that will eventually solve this. And I realized that the code is now not a macro. You can still see that URL. There used to be a compound in front of it. But what you can see is that you now get a compile time failure, which actually tells you the URL is malformed. And you're not building the project, right? This is right away after you've written the code. So it's immediately feedback, and you can directly improve your code accordingly. So the same is true for warnings. What I always used to do is use the compound warning, write down to-do, colon, and then the to-do itself. This could be a small little improvement for your code base to keep track of those to-do, if you will. So one macro can have multiple roles. There's freestanding ones and attached ones. And macros are a really complex topic. If you look at the WWDC sessions, we're now used to like the 15, 20-minute sessions. I believe the macros one was one of the longest, like 45 minutes. And I'm trying to now squeeze this all in 30 minutes. So I'm not going over all these roles. Instead, I just want to show you the examples that we had before. And I think it clarifies it well enough. We have the to-do and the URL and the preview macro. They are freestanding on their own. They're not attached to a class, to a struct, to a method or a parameter. They're freestanding. Whereas the other macros that we saw, they all have like a buddy, you could say. Yeah, so I mean, it's with all talks, right? Like you get inspired here, but as soon as you really want to work with anything, you will look this up. So when you start writing macros, read up on the roles that exist and see which one you really need for your macro. And this is the example we saw before. And you can see that this potential macro, and I believe there's actually an open source variant of this, has multiple roles. And each role has its different purpose. So you want to add conformance to a protocol. You want to add a member, which in this case is an enum. You want to add, that was a peer, and you want to add members, which are the initializer in the method. And you can see that each role will kind of like have its own, single purpose, helping you to define all the feature behind the macro. So how do I create a macro? I will go into an example and show you a bit of like the structure in the internals. And it all starts by just creating a new package. This is actually new in Xcode 15. You have package templates, which are pretty great. You don't have to use the terminal anymore. And one of the templates that is available is a Swift macro. And the project looks like this, and it's probably pretty, overwhelming. There's a lot there, but I'll go over it in a little bit more detail. Because a macro exists of two packages that depend on each other, whereas your app only depends on the first package. And that first package defines the macro interfaces. It basically tells the compiler, these are the macros that are available that you should be aware of. And if you need to compile anything with that macro, the macro is defined, in this case, externally in an external module. We gave it a similar name, and we also mentioned that the macro class file that you need to look for is URL macro. So in that second package, you can see that structure coming back with the same name, right? It's the URL macro again. And we conform it to the expression macro protocol, which requires us to implement a certain method. Each role comes with its own protocol, with its own methods that you need to implement and work out accordingly. The method is throwing. It's a convenient way to tell the compiler, now you need to throw an error, and tell the user the code is wrong right away. In this case, the malformed URL we saw earlier before. And this is a simple example here. We're just returning like plain code. You could see this as the replacement of the line of code where the macro is defined. So the macro goes away, and the output code is being used actually at compile time. And that will be the code that you see if you expand the macro. So like I said before, your app only depends on the first package, and that first package will depend on the actual implementation of the macro. This is mostly done for caching purposes. It's pretty awesome, by the way. This is a checklist. Okay. So yeah, there's another package that is really important. I think it was briefly mentioned before in one of the talks about Toist. It's Swift syntax, which is actually a great package for parsing Swift code as well as generating Swift code. And for those that are really aware, I'm actually cheating here a bit, but this code creates like the code that you see on the bottom. So it's a pretty straightforward, simple version of generated code. But if you only use Swift syntax, this code would actually look like this. And you don't want to do that. And this is basically because you have to define every single piece of the code. So the colon, the var, the space, everything. And you need to, make that parent, child, and so on. It took me, by the way, quite a while to make this. It's actually working, but it was pretty, challenging, so to say. But yeah, this makes it much easier. And this is actually developed by Apple for macros specifically. Swift syntax is open sourced, developed by Apple, and inside that repository, there's another package called Swift syntax macros, which comes with this string initializer, which is easier for us to understand when we write macros, but also for your colleagues, your other developers that come into the macro, have no clue what's going on, and if they need to adjust the code output, well, this is much easier to understand. Go check out the Swift syntax repository either way. There's a lot of macro examples that have been used for the proposal. So they contain like all kinds of different macros to really show you what is possible with macros. So it could be a pretty cool way to understand what macros can do. So actual implementation examples. I want to go back to this URL macro. We make it conform to the expression macro protocol. That's the first thing we do. And it requires us to implement this method, which I want to zoom into a little bit more. Like I said before, you have a communication channel with the compiler. You can get context, like what is the piece of code at line number 10, or you can throw an error or a warning to watch the compiler and tell him to show that to the user. The node is actually the macro. And it's your access entry to get the parameters that are filled into the macro. And for this particular example, we're mostly curious about the URL value that we want to validate. And to do that, this is the Swift AST Explorer. It's a public website. It's also open source, I believe. And what you can do on the left-hand side, you can fill in the URL. And on the right-hand side, you will see the output. Basically, that big piece of code that I showed before is being outputted there. And for this macro, we want to zoom in on a specific part. We can skip the first kind of like parents and directly get into that detail that we need for getting the URL. And it translates back like this. So you first access the node and you get the arguments. And from that arguments list, you get the expression. You then want to get the segments, the string literal segments, and depending on your macro, it's either one or more. With our URL macro, we only have one URL value that we need. You want to make sure it's not a dynamic URL that needs to be evaluated. We want to have a static string kind of, so the literal segment is being parsed here, and we will get the actual URL value later, because first we want to make sure if this card fails, we want to throw an error that there's a wrong input value. And this is basically another error for our URL macro compared to the malformed error we saw before. If this passes, we can get the URL string value. And now the real meat of this macro appears. And it's actually nothing more than this. We try to create a URL which will return nil if it's not a valid URL. And iOS 17 actually changed something, I found out. So the example I saw before with a space is now seen as a valid URL in iOS 17. So maybe it's a good one to check out for your project as well after this talk. But yeah, this is how you fix it, and that makes sure that the validation is actually correct. We can throw an error if the URL is malformed, and like we saw before, we can return the actual output code, and this is the up-to-date code where we use the raw string initializer. So this is the macro error that I used before. You can make it conform to the custom string convertible, which is great for debugging purposes, by the way. So it allows you to create a custom description, which is much more descriptive. Look at me. Look at me. I always wanted to do a meme in my talk, right? It's really bad, but I mean, you're basically the compiler now, right? You can communicate with the compiler, and you can adjust the code, and you can read it, do something with it, and create different code that you want to use. It's pretty awesome. So it might, at this point, look pretty nerdy. Who thinks you want to write a macro at this point? Okay. Well, maybe I did a good job then. I'm not sure. But either way, for those that don't want to do it, you can still benefit from macros. And that's pretty great because, I think it's powerful and it makes the language much more rich. Debatable, but I'm a Swift fan. And this is a great starting point. This is an open source repository, and it lists all the macros that are available today on GitHub. And there are some extreme examples, but there's also a few examples that you really think like, oh, wow, I never knew that I needed this. And this is an example. In Swift UI, if you write custom environment values, you need to write quite some duplicate boilerplate code. And I'm always thinking like, why? It's can it not be simpler? And this would actually be a macro that I would directly use today because this makes your code much more readable. And the code is behind the macro, and I'm fine with that because I don't necessarily care. And it might be even safer as well. It makes sure that it's well defined and it works as expected. This is an actually interesting one. There's both this public version and as well a version from Apple where Apple demonstrates the potential future of testing in Swift. But you can see that in this case, the assertion we have in place is explained in much more detail. So debugging a failed test becomes much more easier because you can just look at the logs that are already there instead of rerunning the test, pause it using a breakpoint, and finding out like what are the values, are they matching my expectation or not. I wanted to show this example as well because this is a bit extreme and debatable if you really want to go as far as this. You could argue like, hey, my networking is working, so I don't really care about the implementation behind, but at the same time, it's hiding a lot of details for your code. So be aware whether this is really something you want to do. But at the same time, it shows really like what macros can do. You have multiple stacked macros on top of each other. You can define methods or macros on methods inside the protocol, right? And this basically defines the endpoints for your API. And if you look at the implementation, so it starts with a provider, with your base URL, then you define the API, and you start to do a to-dos endpoint. But what I enjoy here is that testing becomes much easier because the mocks are available right away. One of the macros created those mocks behind the scenes, so writing tests for this could actually be much simpler. You don't have to write those mocks yourself. Once again, debatable whether you really want to use all those macros because it's also a learning curve that you introduce, right? Like all your colleagues need to understand this as well. And it's all, well, not fundamental logic that you'll learn if you learn Swift, so be aware. This could be a middle ground. This is the spyable protocol. In this case, we have an image fetching protocol which comes with a method, fetch. And the spyable macro generates this code behind the scene. And for my tests, this pretty much matches what I often write to validate the output. It's pretty nice. But the first thing that I thought, like, because macros only have access to the file they are defined in, you can't define the macro in your test target only, which means that this spy is generated in your production code. And it's still early days for macros. It's still early days for this repository as well, but they actually improved it. where you can now generate the code with the if debug around it, which means that the code will only be generated for your debug code, for your tests. So this could actually be something you can use right away today. There are a few great examples when not to use macros. It could be very tempting to put like a whole custom Swift UI view in a macro, so all the logic is away behind the scenes and stuff. But you shouldn't do that. It's really for reducing boilerplate code and make that reusable. And macros are cached as well. So things like dates or random numbers accessing global properties at that moment of time when the macro is evaluated will potentially result in unexpected outcomes if you really depend on that in your macro. Same for networking and file operations. You can't do that. So it's really restricted, but I think that's the power of macros as well, because otherwise we would do things that we shouldn't do. And the future, I mean, the vision describes it, and I think I completely agree, and I can't wait to see what it will deliver. The composable architecture, it's a pretty famous framework from the Point 3 guys, I believe, and they introduce a lot of macros as well. You see that macros are being adopted now in the community more and more, and I think it's the starting point where the Swift team can't wait to see what we will build with macros, and they will definitely start adopting it eventually. The result enum is actually an example, right? Community-driven eventually became part of the actual language. I see that happening with macros as well, and we're just getting started. I believe this is still correct. So yeah, that was my talk. Hopefully you get to know a little bit more about macros. Hopefully it's not too intimidating. I got quite some articles about it as well, so you can read up on it a bit more in your own time. And yeah, I just wanted to briefly highlight a developer tool that I built as well. Go check it out. It helps you hopefully build apps faster. And there's a nice giveaway on this QR code, and I believe it's also in Slack right now, so you can check the link there as well. That's it. Thank you very much, and yeah, if there are questions. I can't sing, I can't dance. Sorry.
We already have 3 questions. The first one says, given that they have context awareness with the compiler, do they impact build time?
Very good question, and something you really want to be aware of, right? Keep track of those build times when you start with macros. It's cached, right? They did a great job on caching, so the initial build time needs to build Swift syntax, and there's actually quite some discussion about it on CI platforms and such. I believe there's a tool called Twist that might help, not sure. But yeah, so it is cached. So in general, your build time should not be impacted a lot.
Okay.
Don't make me accountable, but yeah.
Okay, so the next one says, when using macros, is there any chance that the compiler may pass and some coding issues may only show up during runtime?
Definitely. I mean, macro is still code, right? If you write a macro, you don't write tests for it, and you can still generate code that is invalid, right? If the URL check that you saw before, if I didn't use that API for iOS 17, the URL with a space would pass, the generated code would be working, and it would still fail at compile time. So like I said, it's no magic, right? The macro generates code, and you write the macro, so you decide what that output code will be. It could just be bugs as well. So yeah, you need to be aware.
The next one says, have you encountered any hard-to-find bugs while working with macros?
I mean, the biggest challenge for me, and I'm still learning as well, right? Macros are super new, and what I really find hard is to find out how to create the right output code or to read the input code. So the case detection example, you need to get the cases of the enum and use that as your input for creating those properties. It's quite some steps, and it's a new way of thinking, and there is not really like a tool that, I mean, we have the AST Explorer that I showed, but it's not giving you the Swift output code that you need to use to get the certain value that you want. So if the AST Explorer is watching this talk, can you make that? That would be great. But yeah, so that is the biggest challenge for me, at least with macros, that makes it for me a bit intimidating to write macros, yeah.
Okay, so does anyone have a question? Okay.
Hi, thanks a lot for the talk. Macros was in my list as something that I wanted to look into.
Yeah.
And the one use case that I'm going to use it for sure is writing mocks.
Yeah.
For sure.
Yeah.
I have one question, and that is there any capability that you are missing from macros that you would like to see Apple implementing?
Right. So there are a few. I think you can't use it with inline parameters as you can do with property wrappers today. And I think what struggles me the most in the beginning, and I think it's solved now with this buyable macro, but back then when I really started looking into it, there was no way to prevent codes from ending up in your production code, right? So being able to attach a macro in an external val seems to be like something I really want. But at the same time, that's not what macros are built for, and it would potentially mean that a macro is able to read through your whole code base to find the actual implementation of the protocol, right? So the reach of the macro becomes bigger, which makes it more complex, harder to cache. So yeah, those are a bit the doubts I had at first that I would say would be great improvements.
All right, anyone else? Over there.
By the way, I've had a discussion this breakfast that apparently it's sometimes intimidating to approach me or anything like that. I just want to say, like, I'm really here to meet you all. So if you have any questions you don't want to ask right now, approach me. I'm tall, but I'm trying to be the kindest person ever. So please do, and I'm more than happy to have a great discussion.
Thank you very much for the talk. I have a question, but more on a design of Swift perspective or language, which is you being so important for all the people here in the community.
Thank you.
I've seen that in the latest years we have a lot of new features of the language. Let's say combine, codable, property wrappers, actors, and if we can continue, like there are still things being introduced. And at the same time, this introduces more complexity to the whole language. Like, what do you think that should, like, are we okay? We should, the Swift language team, we should continue adding features like this, or how? I mean, I think macros are great, but then every feature that is added has a lot of potential, but then we end up with a language that it's a lot of different, has a lot of different aspects. So what do you think about that?
Yeah, I think this is a topic that you hear more and more on social media as such. But I think the important message is that you don't necessarily have to use all the features that Swift offers today. And I think there's debates about macros as well. Should we now write everything in macros? But if you take a step back, I mean, we're all going to use the prefill macro. Even though macros are super complex, and you could make this discussion a truth, like, okay, Swift becomes too complex, we're still super happy with the fact that we have that prefill macro, and it does a lot of things for us behind the scenes that we don't necessarily have to care about, but we just benefit from the implementation. And I did a talk on generics as well, where the same question appeared. And these are all features that replace a certain boilerplate code or repetitive code. But if you're getting started, just write everything in one file and repeat it, and doesn't matter, right? You're getting started, and by the time you feel like, okay, I've rewritten this like 20 times now, I want to look into like a way to advance to the next level for myself and reduce boilerplate. That's the moment you can potentially adopt property wrappers or macros or take your own pace, right? And I believe we should be super happy with the fact that Swift is evolving so quickly and bringing in so many great features. Like when Swift appeared, I wrote an app in Swift 1.1 and I could basically drink 3 coffees before the build was done. Like, it was terrible. And look where we are today. It's so much better already, and it's continuing to evolve. So yeah, take your own pace, pick what you like, and don't make it too difficult for you if you feel like being intimidated by certain features, and just accept that there's people that do more complex things. That's fine. That's my opinion, at least, about it.
Okay, let's give a big applause to Antoine. Thank you so much for coming.
Thank you, Lara.